This is the final video in the DevOps and infrastructure section. It's going to cover how to set up the ipfs-bch wallet service. This is a couple Docker containers that spins up an IPFS node, and it allows you to pipe access to bch-api over the IPFS network, and that allows for censorship-resistant access to the blockchain. This is useful both internal to an organization or company, but also globally for the wider community. Another good reason to run the software is bounties. We offer the Permissionless Software Foundation offers bounties for running certain pieces of infrastructure, and this is one of them. So this wallet service hosting bounty, it's currently paying 75 PSF per month. That may change, but this is a good way to sort of recoup the cost and help the wider community by giving access to your infrastructure, to your instance of the Bitcoin Cash blockchain and all the infrastructure that you've set up in these previous videos. So the steps for setting this up is that we want to clone the repository normally, like we have before, customize the startup script, customize the Docker container, add a swarm key, which is what we use for our private IPFS network, and then we can test that everything's configured correctly using the PSF-bch wallet, which is a command line wallet that will be covered more extensively in other videos. So let's go ahead and dive into it. I've got my machine here with the different Docker containers. Let's see if I go up to the infra directory. We've got the bch-api and the bch.js folders that I installed in the previous video, as well as the full node, fulcrum, and SLP indexer, which is our core infrastructure. And here, if I do docker ps, I can list all the Docker containers that are running our different infrastructures. So start by going to github.com, the Permissionless Software Foundation GitHub group, and find the ipfs-bch-wallet-service repository. Go ahead and clone that. Okay. And then following the same patterns, if you go into production, Docker, there's a startup script and a Docker Compose file like in the other projects. So what we want to do is take note of our different ports. So bch-api is running on port 3000, and the SLP indexer is running on port 5010. And that has its own Mongo database on port 5555. So we want to make sure we don't conflict with these port numbers. So I just opened up the start production script. Let's go ahead and edit that. This mnemonic is used to create end-to-end encrypted communication, and the easiest way to swap that out with a new mnemonic is open a private browsing window and go to wallet.fullstack.cache, and that'll automatically navigate you here to bchn-wallet.fullstack.cache. And click Create Wallet, and then click that copy button and copy the mnemonic from the wallet, and then you can close the window. We don't need it anymore. That just generated another valid 12-word mnemonic that this will use to, this is simply used for end-to-end encrypted communication between this node and any other node on the IPFS network it talks to. The cord name is sort of the human readable name that your node will identify itself as. I'm going to call this temp demo wallet service. You can skip the circuit relay stuff, leave that commented. The debug level is like how much information that is displayed for debugging purposes. I think 0 is the least. The default is 2, and I think 3 is the max. Here on the API server, we're going to comment this out because we're using our own local API server, the BCH API. So that's going to be leave the S out, and then so leave the S out because we're just using regular HTTP, and then you can use the 172.17.01 Docker subnet port 3000, and then don't forget that v5. We're not going to get a JOT token at startup because we're not using fullstack.cache. So these lines don't matter, but you definitely want this. We definitely want to comment this line out so it doesn't try to go get a JOT token from fullstack.cache when it starts up. As I mentioned, the default port for Mongo needs to be changed to 5556 so we don't have a port issue. Also, this is going to come up and try to be accessible on port 5010, which our SLP indexer is using, so we're going to change that to 11. And then these are the ports that the IPFS full node will use. We'll leave those alone. So that's changed, and then we need to make those updates as well in the Docker Compose file. So the Mongo container, change that to port 5556, and we can leave the IPFS container alone, but the BCH wallet service, we need to change this to port 5011, both on the host and in the virtual machine. I think those are the only changes we need, so let's go ahead and build this container. Okay, now that the Docker container is compiled, let's bring it up and see if we have any issues. Okay, it didn't complain about any ports, so that's good. BCH wallet-service. So, looks like it's starting up. Looks like it's having some trouble. Actually, that's to be expected on the first time. If we go docker ps, docker logs f, the IPFS container, so this is the IPFS node. So that's great. At least it came up and it didn't complain about ports. That's progress. What we need to do now, so I'm bringing the Docker containers down, and what we need to do now is add the swarm key so that IPFS is on its own private network with the rest of the nodes in the PSF community. So that should come down. Yeah, ignore these warnings. These don't matter. So in the production directory, you can see that there's a data directory now that exists. And in the root directory is this swarm key. This is the private key that lets the IPFS node join the private IPFS network that the PSF, that the other nodes for the PSF community use. So if you go into production, go into that data directory, go into go IPFS and data. Here's where the config file lives that lets you control the configuration of the IPFS node. We're going to copy that swarm key, and we have to use sudo because this directory was created with root access by the Docker container. We're going to go up 4 directories, find that swarm key, and copy it into the current directory. Okay, there's the swarm key. So now when the IPFS node comes up, it'll join our private network. We can go back into the Docker directory. Let's clear the screen, bring the containers back up. So now, if we look at the IPFS container, we can see right here this new line that tells us that it found the swarm key and it's now joining the private IPFS network. And if we look at the logs for BCH wallet service, Scroll up to the top here. This says undefined. That's good. That means it's not going to try and get a JOT token from fullstack.cache. These first two lines, this means it's successfully connected to our two Bootstrap nodes. And then these other messages down here connected to peer private orbit DB. You'll see that over and over again. These are just telling you that it's connecting to other nodes on the network. So it looks like everything is working pretty good right now. In fact, I'm just going to go ahead and leave that log flowing by. So over on the dev machine, this part's going to be a little hand wavy because I'm going to cover it in more detail in other videos. But so now I'm on my dev laptop, and what I want to do is connect to the IPFS node that we just started and test that I can successfully pipe access to the blockchain over IPFS this way. So on my dev machine, I'm going to bring up IPFS node in daemon mode and enable pub/sub experiment, because we heavily use pub/sub channels. And again, you can see that I have the same swarm key, so I'm part of the same private network there. And then here I have I'm in this ipfs-bch wallet consumer. So let me talk for a minute about what we just did. If you go to the Permissionless Software Foundation website, psfoundation.cache, and go to the blog, there is a blog post called Realizing the Web3 Cache Stack. So here in this picture, in fact I have a bigger version here, what we've completed is this global backend. We've got our infrastructure and bch-api. We just set up ipfs-bch service provider, and we're piping that connectivity over IPFS network. And then this ipfs-bch wallet consumer is the mirror image of the provider. So this provides access to the blockchain, this consumes access to the blockchain. So that's what we're running over here on our local machine, ipfs-bch wallet consumer. And there is I already have it cloned. I installed dependencies with npm install, and there's this shell script directory and this local external IPFS node. And I think I left most of this, you can just see what I'm using. I think I left most of this as just default values. And I'm going to run that local external IPFS node shell script. And so, like I said, this is a mirror image. It's using this local IPFS node that I set up. Again, I'm looking for that it's successfully connected to these Bootstrap peers, and it's sort of off and running. So now I've got an IPFS node on the server that I'm setting up, and I've got an IPFS node running on my local machine. And then here in PSF-bch wallet, I'm covering this quickly because I'm going to go into more details in other videos on PSF-bch wallet and the IPFS wallet consumer. In this command, let me clear my screen here. I can go bin run wallet service. So this command line wallet, actually I should take a step back here. If I go bin run conf-k rest server, this is going to show me the rest server that I'm connected to, and I'm actually connected to freebch.fullstack.cache, which is not what I want to be connected to. So just running the conf command, this sets different configuration variables, and the main thing we're focused on here is the rest server. So I actually want to change the rest server to localhost port 5005. If we go back to the window running the consumer, I know it's on port 1005 because that's what it says at the startup right there. So that's how I know to connect to port 5005. And so what this is going to do, and if I run it with just the -k REST server, I can confirm that the configuration setting went through. So what we're doing is we're using PSF-BCH wallet to control the local instance of the BCH consumer in order to talk to the wallet service that we're trying to set up. So now if I go, so if I do help, I can see all the commands. But the main one we're interested in, we're only interested in a couple of these commands, is wallet service. And this will list all the wallet service providers it can find on the IPFS network. So going back to this diagram, this IPFS network is like a bus, and our wallet only needs to connect to one of many services running on the network. And so here's the temp demo wallet service, the human readable name that I gave it when we set it up. Here is its IPFS ID, so that's what we're going to connect to. And it looks like we're already connected to it, but if that's just randomly by chance that it happened, you can do this -s command to tell it specifically which wallet service you want to connect to. So just for good measure, we told it explicitly we want to connect to this service provider that we're testing. And so now that we're connected to it, we can run wallet service -test. And this will run through a series of standard commands to see that'll test the different pieces of infrastructure that we're connected to make sure that everything is running or not. Okay, so this is good. It said wallet successfully initialized. Was able to talk to the fulcrum indexer. It got an expected response message when it tried to broadcast a transaction. And it was able to pull a public key successfully from the blockchain. So that's great. It looks like everything's set up and running correctly. A few things. So this is our wallet consumer. You can see what it's doing is it's making REST API calls to our local machine, to our local wallet consumer. And so you can see some of the data, at least these API calls coming through. And then on the server side, it's pretty noisy, but hopefully we can see, looking for an example. Okay, so here's an error. This is where it was trying to broadcast a transaction. It got the ID, type request, method BCH. This is an internal error, but then it responded with that data. Here's another one. That's the RPC ID, type request, method BCH. So that's what it looks like on that side. And then we can also look at our BCH API, tail 20F BCH API main. So if we run that test again, ultimately what's happening is we're using PSF-BCH wallet, which is talking to our local IPFS consumer, which is going over the IPFS network to our local installation of the global backend. And so we're just following the network connection and the information as it flows across the network through these different pieces of software. So I'm going to run this test again, and we can actually look at the output of BCH API and see specifically which endpoints it's hitting. Here's like a 404 that would normally give me like a pause, because that means it tried to look for something it couldn't find, probably an address that doesn't exist. And then again over here we can see right here we can see there's the RPC ID request method BCH, which is making it to BCH API and then back across the IPFS network to our local node. And so this is great. This means that everything is set up correctly. If some of these fail, or all of them fail, you just have to go back to first principles and go through this network stack and figure out like in which piece of software is the issue occurring, and debug from there. And if you're really stuck, you can reach out for community help at the PSF Telegram channel. So there's the Permissionless Software Foundation channel, which is for general talk with the PSF, and then there's this BCH.js toolkit channel for technical support, and so that's at t.me/bch_js_toolkit. So this is where to go if you get stuck and you need help debugging and troubleshooting. And this concludes the video series of DevOps and infrastructure. At this point, you should have a desktop PC with 32 gigabytes of RAM, 1 terabyte hard drive running Ubuntu, which should cost you around $400 or less, and it's running all the infrastructure you need to collect the bounty, if that's what you want to do, or just to simply run all the infrastructure you need in order to develop your own apps to interact with the Bitcoin Cash blockchain and tokens and all that good stuff.